Okay. I want you to solve for all the angles that have a letter attached to them. So just to be clear, E is talking about that angle formed between these two. This is on page 31. Okay. So E is right here. Okay, that's E, and then D, F, and so forth. So do it on the side here, but I also want you to justify how did you get it, right? So you want me to get you started? I'll get you started. So if you wanted to solve for A first, then you just go like this. And again, I will highlight the fact. Althea, do you mind? It's not Althea, right? It's I'll get your name later. But can you turn off this one? Yeah, this. Yeah, thank you. What's her name again? Athena. Sorry. Last semester I had an Althea sitting on that corner, so it's throwing me off a little bit. Sorry about that. So we've got these two parallel lines there, and you can only travel, right, one transversal at a time. So if you're thinking A, I would say, well, let's travel along the transversal connecting to the other parallel line. Let's do that. So you now gotta forget about all the other lines that are happening. Just travel along this one. What do we call these two here? These are called alternate interior, right? And we know that they're congruent. We know they're congruent. How do we know that? Because of this, right? This is guaranteeing that fact. So all you would have to do is 44 and then Y, alternate interior angles are congruent. To be honest, that would be the only way right now that you could make this work. Okay. And then you go from there, right? Then you decide which other one you want to do. You don't have to do it in order. Just travel along, see what you can find. So I'll ask you to do that, and then the one at the bottom as well, and then we'll take it from there to go polygons. Okay? We did. I don't have the key in front of me, so you gotta help me out, okay? If I make a mistake, don't let me do the whole thing and then tell me I made a mistake. That's all I'm saying. So A is good. That's 44. I'm gonna focus on E here because I see a triangle. So I choose to go with that. And so I'll leave some space for the number. So that would be 180. But don't erase, okay? If you did it a different way, you're probably okay. So I'm going to subtract that A from it. And I will do this. 83 degrees. And you could also say sum of triangles 180 if that's what you use. Maybe use something else. Maybe use vertically opposite because you found F first. Or maybe you found D first and then use straight angle. It doesn't matter. So I got this, I got that. I'm going to find F next because it's fairly simple. That's just 83. And that's vertically opposite. Angles are congruent. And this may be where it's frustrating because you're like, I want it to be exactly the way I did it. So unfortunately, that's not going to be the case. D, I will do that next. That's just, you can either use the straight angle here or you can use a straight angle here. But regardless, they add up to 180 here. So 180 minus 83, that's 97. So 97 degrees. And I'll just go straight angle is equal to 180. So I got D as well. I'm going to go with B now. Angle B. Technically, they should all have an angle symbol in front of them. There we go. Angle B is, I see a triangle here as well. So you can go 180 minus 38 minus D, which we already know is 97. Okay, so 180 minus 38 minus 97, that's 45. And you can just say sum of triangles equal to 180. Are we doing good so far? Yeah, okay. That's good. What else is left? C is right there. You can either travel along this, you need a different color here, right? These are parallel lines. If you want to travel along that transversal, and you notice that these are alternate interior as well, like that. So they're alternate interior. So you can use that, or you can use another sum of triangle, whatever you feel like it. Sometimes I do tell you to only use one property once. So you have to use something else for every single line. But I will make it possible. It will be possible. You just have to like zoom out sometimes. So C is 53 technically. Does that work out if you do the sum of triangle? 180 minus 44 minus F. Yeah, it's 53. So regardless of how you do it, or sum of triangle, right? Regardless of how you do it, you get that. Okay. I'm just gonna leave it at that. The bottom one here, I will post that one. Okay, I'll post the key to that one. I'll find it later. But I do want to mention something. It's a special case if it's a parallelogram. If you come with me here, what's so special about this is that you have these two lines being parallel to each other, as well as these two lines being parallel to each other. Parallelogram. That's what that the shape represents. What does that mean for us? It means that, right, if you want to focus on these two parallel sides here, right, you can travel along, you can make this a transversal and travel along this way. And you can see that you've got alternate interior angles there. So the 35 comes over to where F is. Okay. And then you can say, well, now I'm going to focus on these two parallel lines. And I'm going to travel along this transversal here. The 30 comes over to where D is. So you've got 30 there, transfers over, and then you've got sum of triangle. You've got vertically opposite here. You've got straight angles. You name it. Lots of stuff there. And also remember, if these are parallel, technically you can turn this into a transversal as well in this case. You know that all of this and all of that adds up to 180. Right? So you always know that if these two lines are parallel, these are CIAs, right? On top of everything. You could use that as well. So it's kind of like a big salad where you just mix everything up. Everything we've learned is still applicable, it still follows us everywhere we go. All right. We're going to park this here for a little bit, and we're going to start polygons, and then everything we've learned kind of comes with us still. So I invite you to go to page 32 here. Polygons. Polygons. Just like to highlight it, make sure that I've covered it. So some terms and definitions here. There's something called convex polygons versus concave, and you're caving in, right? Caving in. So we will not be working with those really. We'll be focusing on convex, this one. So, sorry, another thing I should say, there's a reflex angle there, technically. Reflex is bigger than 180. That's what defines a concave I like to say, hey, look, it's caving in, but really from the inside, you have a reflex angle on the inside. Regular polygon versus irregular. Okay. So what makes a polygon regular versus irregular? And this is it. Okay, this is the checklist. For you to be in the regular category, all sides must be congruent. I'll just use that symbol, the equal sign with a third wave. Okay. And as well, all angles must be congruent. That's another must for you to be considered a regular polygon. Okay. And so everything that doesn't meet the criteria, guess what? You put it in the irregular category. Okay. So that's the main difference. So here you can tell this is an equilateral triangle. Guess what? All sides are the same, correct? And what are all angles measure in an equilateral triangle? They actually measure 60, 60, and 60. Okay. Now, a square would be considered regular as well because you've got the symbols indicate all sides are the same. And guess what? All angles are 90. So it's regular, regular. Okay. When you go to irregular, I want to, for example, point out this is an isosceles. Isosceles triangle. These two angles will be the same. You can make the markings there. But this one at the top will be different. Okay, so two sides are the same, two angles are the same, but it's not quite enough to be in the regular category. Okay. Watch this one here. This is a rectangle. You've got all four angles will be 90. Oh, we're close. All angles are the same, correct? But the side lengths are not. So all angles congruent, check. All sides congruent, and fails, right? So it turns into an irregular. So there we go. Sometimes, I will ask you what makes something regular or regular, so just keep this in mind. All right, keep going. Properties. All polygons have interior and exterior angles. I will talk about that in a bit. The interior and exterior angles are supplementary. There's a sum of 180 degrees. Okay, so what I want to say here is, maybe this is what you should write down, is that the interior angle plus the exterior angle is always going to add up to 180 degrees, and you will see that now visually. Okay, so look at the shape. I think you should right away realize this is an irregular polygon, correct? Polygon is anything that is closed in. A closed-in shape is a polygon. So triangles are polygon, squares, rectangles are polygons. This is a polygon. This is actually a 1, 2, 3, 4, 5-sided polygon. Pentagon is the name we have for it. So I want you to write this down here. This one right here, I'll do it here. N is equal to 5 sides. That's something I want you to know, that N represents the number of sides for us in this unit. And let's dive in here. Go to this corner at the bottom of the shape. And what I want you to do is call this angle here as an interior angle. I'm going to call that I. I'm going to use a red pen. That would be considered one interior angle. How many interior angles does this shape have? Well, let's see. 1, 2, 3, 4, 5. It's got 5 interior angles. The angles are formed between the sides, where the sides meet. So it's got 5 interior angles. So we're going to say 5 interior angles. And what about the exterior? Exterior means outside. This is how you identify an exterior angle. I'm going to start with this one at the bottom here. So what you do is you pick any of the 2 sides that meet at that corner. I'm going to pick this one. You travel along it till you get to the intersection, and then you just keep extending it like this as a dashed line to the outside. And I'm going to use our blue pen for this one. So that angle formed here, that's what we call the exterior angle. You can tell that they add up to 180, can't you? It's a straight angle, right, between the 2. And the same thing happens here. Let's keep traveling this way. So if you travel along this side and you get to the top here at the corner, you keep extending it the same direction as this side. It's almost like you're just extending it. And guess what? There's your other exterior angle. And let's do that all around. I'm going to travel here, extending it like that. Keep traveling on this side, extend it like that. Keep traveling along the bottom. And there you have it. You've got how many exterior? 1, 2, 3, 4, 5. Right? 5 exterior angles. So when n is equal to 5 sides, we know we'll have 5 interior and 5 exterior angles. That's a property as well. And so I will just show you here. I plus E one more time is equal to 180. Supplementary. Sum of exterior angles is always 360. Guaranteed. Sum of exterior angles always 360. Regardless if regular or irregular, regardless of the number of sides. That's pretty cool, if you ask me. Okay. Let's keep going. Should I show this? Do you just trust me or no? About this property? Some of you won't care. It's like, I'm just going to write it down. I'm going to highlight it, and then we go with it. But I'm going to go to this here. If you make an exterior there, that's 120. You make an exterior there, that's 120. You go to this corner, another 120. 120, 120, 120, that's 360, isn't it? Okay, what about the square? There's one here, there's one there, there's one there, there's one there. 4 times 90, 360, isn't it? Right, so it doesn't matter. I just want to show that point that it's always true. It doesn't matter if it's regular, irregular. It's going to be 360 every time, okay? It's a pretty cool property. So here are the formulas that I need you to have on your study sheet. This is on page 33. Remember, n represents the number of sides. This is very cheesy, I know, but I'm going to help you remember. You're supposed to be psyched about polygons. You see that? Take it or leave it. So we've got these 5 formulas here. S represents the sum, right? The sum of all interior angles. If you want to find out what all interior angles add up to, you use that formula right there. Number of sides minus 2 times 180 degrees. Let's try that with a triangle. How many sides does a triangle have? 3. 3 minus 2 is 1. 1 times 180, 180. Small example there. I, right? Look at that. It's almost copying the sum, right? It copies that down, but what do we divide it by? The number of sides. So if you want to know the measure of each interior angle, that's the formula you use. The measure of each interior angle. That's I. Okay. If you want to know the central angle, C stands for the measure of each central angle. You use this formula. 360 divided by n. If you want to know the exterior angle, guess what? They're exactly the same formula. The exterior angle, you just got to go 360 divided by n, and this has to do with what the property that I just talked about, right? If it's 360, then you divide it by n like that. And the last one, the number of diagonals. I will explain that to you in a bit, right? D stands for the number of diagonals that can be drawn inside the shape. You use that formula. I need you to understand that you can't use all of them in every circumstance. Ice, the middle here, okay? These three will only work if it's in fact a regular polygon where we're assuming all angles are the same, okay? So that's, I will make like a little bracket like that with the same color where I say, hey, this only works with regular polygons. Everything else you can use with other polygons that aren't regular. What's regular? All sides, all angles are the same. And by the way, most of them are going to be regular. Most. Let's apply what we've learned here. It says label ice, right? Interior, central, and exterior. Then calculate. I want you to calculate what does that stand for? The sum of interior angles, the interior angle, central, exterior, and the number of diagonals. So let's label. First, I just want you to label 1. You go inside, you go to any corner, and just call that I. That's angle I right there. That's the interior. I'm going to zoom into that. And then just find one exterior. I'm going to choose to have it down here. So I'm going to travel along the bottom here and then just extend it. That's my exterior angle. And the central is new. But central, think of center, right? We're going to go right to the center of the shape, make a dot right there. And then you have to just pick one side, any side. If you want to pick this side, you go slice it like that. You go to the other end of that side, slice it again. That's one central angle right here. So that's what we call C. Okay? The angle formed when you make that slice is called C. I will say this now. How many sides again? 1, 2, 3, 4, 5, right? 5 sides, 5 interior angles, 5 exterior angles, and how many central angles do you think you'll have? 5 as well, because you can make the slice all around. You've got 5 central angles, but we just labeled 1 of each, okay? Because I just want you to know where they are. It's important for you to know where they are. So let's calculate that. The sum of a 5-sided, we usually put in, you don't have to do this to be honest, but this is reading the sum of interior angles of a 5-sided shape is going to be 5 minus 2 times 180 degrees. And that's 3 times 180, which is 540 degrees. Okay, so that's the sum of all interior angles in a polygon. We cut it there. the interior angle, like the measure of each of just one, that is, you go I of a 5-sided shape is 5 minus 2. You can use our previous work here, but we're going to divide it by n, which is 5. If you look up here, this part right here, I'm not going to redo it. I already know that this is what? This is 540. So I'm just going to go 540 divided by 5. And if you do that, you get 108 degrees. There you have it. Each interior angle, each one of these eyes, right, is going to be 108 degrees all around. Cut it there. Central of a 5-sided, that's super easy. It's just 360 divided by n, n is 5. So that's going to be 72 degrees. Exterior angle of a 5-sided, it's copy paste, guys. It's 72 degrees. However, copy it down, and I want you to look for here. You could also have gotten this by using the fact that, remember, the interior and the exterior are considered supplementary. You could have taken this away from 180 and then gotten that as well. So I'm going to add that here. Or E is 180 minus 72. Sorry, 108, guys, sorry. On Mondays and Fridays, you have to be very careful when I write my notes. Maybe wait a second or two before you copy down. Okay, so either one of them would have gotten you the exterior. And last but not least, D is going to be too tight here for me. So I'm going to do that over here, D of a 5-sided. I'm just looking at the formula. It calls for n times n minus 3 divided by 2. That's just 5 times 2 divided by 2. I can cancel that out, right? Times 2 divided by 2. It's just 5. 5 diagonals. So this is not an angle that you're finding. You're determining how many diagonals you can possibly draw inside that shape. If you want to, I'll give you a little demonstration. So to draw a pentagon, that's the only one that I can do pretty well. So you just make like a roof, and then you come in a little bit and close it at the bottom. Still doesn't look that good, but anyways. So here's how this is considered a diagonal, guys. You go from this corner to 2 other corners in this shape. Obviously, you're not traveling along the side, right? That doesn't count. So that'd be 2. Then I'm going to another corner here, and I'm going to go 3, 4. 4 diagonals already. And I'm going to use a different color for the last one. The only other one left is from here to here. So you've got 5 diagonals. This one isn't very common, but I think it's worth knowing how to do it. It would just be plug in and calculate, right? So this one, I'm going to box that in like this. Trying to come up with another acronym that is not as cheesy, but not thinking of one right now. Anyways, so this is basically calculating all the things that, using all the formulas I just gave you, okay? All right, let's keep going. I want you to spend some time here I'm only going to ask you to do it once. So look at this polygon right here. I want you to find all of those, like the psyched ones, and label ice on here. But I want to give you a tip, okay? Because a lot of students miscount the number of sides, and it's very frustrating to you and to me to mark it. So the first thing you always want to do when you see a polygon is count the number of sides. And this is what I would suggest. Put a check mark on the one you start with, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? That way you're not double counting because you put a check mark already. So you stop here. So this has 11 sides. Now that you know that, you go ahead and label ice on that shape. And then I want you to calculate all of the other ones using the formula, right? The sum, the interior angle, exterior, all of those. So try that, and then I'll continue. I just want to make sure you know how to do. If you just look up here, I have the key up here. So just make sure you check and you got the same answer. So the sum of all the interior angles is quite high. The more sides the shape has, the bigger this number gets. Okay. The interior angle is this, so round to 2 decimals when that happens. Your central angle is this. Your exterior angle is same as the central. Right? You can use either formula, and there you should have 44 diagonals if you did this right. So I go 11 times 11 minus 3, and you get 44. So I hope that was all right. Let's go and put a little twist to it. Let's go to the last one here. So I will expect you to know, without me telling you, hey, solve for the exterior angle or solve for the interior angle, I'm expecting you to know, okay, I'm looking for that angle. This is the formula that I'm going to use for it. I won't necessarily tell you what formula to use, right? So let's look at this one. The first thing I'm going to do is count the sides. I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did you count 15? We're good? Okay, 15 sides. Very important because that everything hinges on that. I'm going to solve for this one here first. That's an interior angle. That one you should be able to do no problem, right? So I'm going to go angle A is going to be found by going 50 minus 2 times 180 degrees divided by 15. That's 13 times 180 divided by 15. And I get 156 degrees when I plug this in. So A is done. I don't have I there, I just have A is equal to that because I know A represents the interior angle in this particular case. And then I'm going to do C next. What is C in this case? It's an exterior angle, right? So I will do that here. Angle C, 2 ways you can do this. You can go not 180, 360 divided by 15, which gives you 24 degrees. I'm going to make a note here, exterior angle. And what is B? Be very careful before you answer. Be very careful. Look at the whole thing. Is B a central angle? It's how many central angles? Okay. Exactly. So I'm going to cut this here. I'm going to do this. Right? That's a central, that's a central. B is comprised of two central angles. Oh, there's another C here. So this is capital C. Capital C is 360 divided by 15, which is the same as this one over here. It's 24 degrees. Angle B is going to be 2 times 24. Okay, so that's 48 degrees. So you got to be careful. When it looks like a central, it may not be. Just count the number of sides that it spans, right? So if I had, for example, gone with 4 sides or 5 sides, just find a central angle, multiply it by 5, and then you have it. Okay. All right. Let's keep going. We'll do some backwards examples here. We're going to go to 36. Sometimes so backwards, I mean use algebra, basically. Sometimes you will be given one of those formulas that I gave you, the 5. You'll be asked to determine, you have to determine a number of sides. So what we will essentially do is we'll start with a formula, then isolate for n. Every single time that's how you start. So the sum of interior angles is 3060. So the sum is 3060. The formula for sum is n minus 2 times 180 degrees. Okay. So what you do is you substitute s, because we know what the sum is. We want to know how many sides this thing has. You can use guess and check, but only to check, right? Not to actually answer the question. I want to see the work here. So you're going to go 3060 degrees, n minus 2 times 180. This is really probably where most of you are going to start, this line right here. And yes, there are many ways of doing this, but the best way I find is the 180 is multiplying this, and you've got a number here as well. So what I will do is I will divide both sides by 180 degrees instead of distributing. Some of you might have been like 180 times n, 180 times negative 2, but I will just get rid of the 180 this way. And then you just grab your calculator and you go 3060 divided by 180, that's 17. Okay? So 17 is equal to, you're left with n minus 2. You no longer need the bracket. And you just add 2 to both sides. N is equal to 19, right? The polygon has 19 sides. So what would I require? I would require these steps, right? Required steps. The first 2 I wouldn't really care for, right? Unless you want to. Some are easier, some are harder. Okay. So I'll finish with this page, and that'll be it for today. A regular polygon, okay, has exterior angles, that's E, of 11.25. Calculate the number of sides algebraically. So I will say, well, this is the formula. I know the 11.25 goes in there. So it'll be 11.25 is equal to 360 over n. This is where we go back to chapter 8. The power of 1. Right? You put the 1 down there. You know you need to cross multiply and then divide every time. So you just show me that work. 360 times 1 divided by 11.25. This actually ends up being exactly 32 sides. The hardest, perhaps, is the next one. You ready? I'm ready to go home. Regular polygon has interior angle of 171. Calculate the number of sides algebraically. Yikes, right? Because we all know that this is what the interior angle looks. That's the formula for that. So this is the hard. I'm going to show you two ways. This is one way. So the 171 will go in there. Okay. So we go 171 degrees n minus 2 times 180 over n. My method is going to consist of, I want to get rid of the, whenever there are fractions on any equation, I try to get rid of that. Okay. And no, you cannot cross multiply divide here. It's not going to work out because there's too much happening here. So what I'm going to do is I'm going to multiply both sides by n. That allows me to get rid of the n there. You don't have a way out here in terms of that. So it's 171n is equal to, for today, I'm actually going to rewrite the whole thing again. But normally I distribute already right away. Okay. So what happens now is you're like, well, can't I just divide by 180 on both sides, just like you did at the very beginning? You could, but there's an n here, right? It's not just a number. So I will distribute here like that. So it's 171n. 180 times n is 180n. 180 times negative 2 is negative 360. Now, what I will do is I will subtract 180n from both sides because I'm trying to combine the n's. You end up with negative 9n, negative, right? It's 171 minus 180, that's negative 9n. Here you conveniently get rid of the 180s, so you're left with negative 360. And your last step here would be to divide both sides by negative 9. Make sure you practice these over the weekend. So that's 40 sides. This is one method. This one, the next one is my favorite. Okay, but most students, I don't know, for some reason they just like this. Nothing wrong with that. But you know what I see? When you tell me that the interior angle is this, I see this. Oh well, the exterior angle is what? 180 minus 171. It's as if somebody tells me if the interior angle is 171, I know the exterior angle is 9 because they're supplementary every single time. So then you can use this formula, which is so much easier, right? So I've just gone off and say, hey, I know this is true as well. I'm going to use this formula. So it's 9 is equal to 360 over n, the power of 1 here. You're going to multiply and divide. So n is equal to 360 times 1 divided by 9. And that is 40 sides as well. So because sometimes you just have to think of it's like, what else is the question telling me at the same time? Not explicitly, but implicitly, and this is it. Okay, so 2 methods you choose for you to practice. Okay, so homework. Hi. Okay, I can go get it too. Is it just done? Yeah, just throw it anywhere. Thank you very much. Yeah. If it's too heavy, just leave it there. I'll take it. Thank you. Homework. I know it may seem like a lot, but I'm going to say 38 to 41. It has a mix of everything. So homework, page 38 to 41. And there's a lot of room. So it seems like a lot. It's not textbook 38 to 41. It's like my book 38 to 41. So you're doing, right? You're calculating using the formulas here. There are some diagrams. You got to be very careful here. Central angle maybe, but not quite. Okay, you got to watch out. Solve for what's missing. I'm just going to give you a hint here. If you go to page 40, look at this one. I made a mistake there. I don't know if you see the mistake. Okay. So yeah, that's as good as my jokes get, guys. So A, B, C, D, E, F. So you want to call this F or something? Let's do it. I think my key doesn't. Oh, let's keep this one C. Let's keep this C there. And we're just going to call this F. I think it's going to be easier, smoother to do that. Okay. I don't know what I do on my answer key, but you'll figure it out because it's the exact picture of this page, so you can figure it out. Some students are confused about this one. How do I get that? Just think about, there's an exterior angle here, and there's also an exterior angle here, right? So just think about it, fill in the blank, and then you'll figure out, and then you've got a triangle outside, right? So be ready for that. That's it, guys. Thank you very much.